this is Priyansi. Welcome back. Today we are going to be discussing three fundamental operations in a one-dimensional array: inserting, deleting, and merging. Next video we are going to discuss searching and sorting, so stay tuned. Let's start with inserting. So consider this is an array over here, and given a position, that is the value of 2, we have to insert a value, let's say 11 over here. So our final array will look something like this. How do we do that? As you can see, the array length of this is equal to 5 and this is equal to 6. So first of all, the first thing that we have noticed, that we have to increase the length of the array. So if our array looked something like this, it'll be really easy to insert this value over here. But how do we go from our original array to this array over here? Well, if you look closely, all we are doing is shifting the elements right one step at a time, right? But if we do that over here, if we do that over here, for example, at position 2, we want this to go to here, right? But if we do that, then this becomes 7. And in the next iteration, this 7 gets copied here. So this also becomes 7. So all we are left is with a bunch of 7s and the original values are lost. What will be a better way to do that is if we do quite the opposite, as is that we start from the end and we just right shift the elements. So this 3 gets copied over here, and now in the next iteration this 5 gets copied over here and this becomes 5, and this 7 gets copied over here, this becomes 7, and now this we can just write 11 at this position over here and we will get our final array. So all that is clear, but we still haven't studied how to increase the length of the array. So what we're going to do is we're going to take a constant fixed an array of constant fixed size, and that size is going to be large, let's say 100, and then inside that we can just accept 5 values from the user and change that to 6, 7 till 99 values. So that's exactly what we're going to do. Let's see the code for that. So this is a code for the insertion in an array, in a one-dimensional array. So we are accepting the length of the array from the user. We are accepting the position at which the value has to be inserted and the value itself. So all these 3 lines can be written with the help of scanf, so don't get intimidated by that. Now we are going to generate a random values for our array, and this piece of syntax will help me generate random values from 0 to 9. So this basically generates random values, and but the values can be large, so we are restricting the values, okay, with the help of a mod. Now we're going to print our array just to see what it looks like, and then we're going to begin shifting our elements to the right. So we'll start at the end, which is the length of the array, which will be our index will be 5 over here, and then we are going to run the loop till 1 less than the position. So if you look at the whiteboard over here, we are going to start at this index, which is 5, and then we are going to go till this index over here. So and all we're going to do is copy the previous element into our index, our current index. Okay, so this is pretty simple, as you can see. And next, once we get out of the loop, is all we have to assign the value to that position, and don't forget to increase the length of the array because you have to print out the entire array next. Let me give you a quick demo then. Let me clear this up. So we are providing the length of the array, the position at which the value is to be inserted, and 11 is our value. And sure enough, we are getting our output. Let's move on to deletion. So let's start with the same example, and in deletion what we want is that given a position for example 2, we want that element to be gone. And so if this is our initial array, this is what our final array should look like. How do we do that? Well, quite opposite how we insert the elements. So in an insertion, we do a right shift, but in deletion, we do a left shift. But if you notice, if we start at the end of the array, just like we did in insertion, then this 3 will get copied over here, and in the next iteration, this previous value, which is 3 now, will get copied over here. So we are left with a bunch of 3's, and our original values are getting lost. So what we're going to do is we're going to start at the position itself, and we're going to copy this next value into our position. So if we start at 2, then we're going to copy the value at 3 into 2. So in our first iteration, this will change to 5, and in our next iteration, 3 will get copied here, so this will change to 3, and we have to reduce the length of the array by 1. So now 5 becomes 4, and this is what our original array would look like. If we don't reduce the length of the array by 1, then we are left with this, but we only want this. So let's check the code for that. So again, we are accepting the length of the array and the position at which the value has to be deleted from the user. Then we are going to generate random numbers from 0 to 9 for our array. We're going to print out the array to see what it looks like. And then we are performing a left shift. So we are starting at the position, we are moving till the length of the array -1. So what does that mean? Is that we are going, if we start at 2, then we are going to move till only 3. Since we are already accessing this value, the index plus, we are accessing this index plus 1 value. So if we move on till array length, then we are trying to access a value that doesn't exist. So we have to be really careful about our limits over here. So all we are doing inside the for loop is we are copying the next value into our current value. That's it. And then we are decreasing the length of the array by 1, and we are printing out the final array. Let's see what this looks like in code. So we are providing the length of the array and the position at which that element has to be deleted. If we do that, this was our array and this was the final array. So let's move on to merging. So there are two ways in which you can simply merge two arrays. Is that if you copy all the elements of the second array into the first array. So you start at the index position, that is len1 of the first array, and then one by one start copying that. And so our first array will look like this. Or you can do something like you can take a third array and then you copy all the elements from the first array first, and then you copy all the elements from the second array. But simple merging is quite boring. Let's do something else. So if you notice carefully, the two arrays that I've taken are also sorted. Now what does sorted means is that they are in either ascending or descending order. Right now they are in ascending order. And what we want is that we want these two arrays to look something like this. So we are merging two sorted arrays and we want the final array to be sorted as well. So how do we do that? And we're going to use a third array for that. Okay. So the question is, how do we know which element goes first? Well, if you look closely, the comparison is not going to be within an array. For example, we know that this 3 in this array will always come after 1 in this array. Okay, like this in the third array. And this 6 will always come after 5. So the comparison is not within the array, but rather between these two arrays. So we have to compare these two numbers, and so on. We have to do a lot of comparisons over here. So how do we do that? So we are going to take three counters, and these three counters are going to be P1, P2 and I. P1 is going to store the indexes of our first array. It's going to be initialized to 0. P2 is going to store the indexes of our second array. It's going to be initialized at 0. And I is going to store the indexes of our third array, also initialized to 0. So I is going to be incremented with every iteration. So our final array is going to look like this from 0 to 6. And because this array, the first array is of length 3 and the second array is of length 4. Okay, so how do we go about this? Well, P1 and P2 are not going to be incremented with each iterations. Rather, it depends on comparisons. And what do I mean by that is in our first iteration, we're going to check is 3 greater than, is 3 less than 1. Since 3 is not less than 1, then we know, since we are storing a sorted array, this 1 has to come first in our array 3. So when 1 comes first, we are going to increment the value of P2 from 0 to 1. Now P2 points over here and P1 still points at 0. So next, I also gets incremented from 0 to 1. So right now, I is now pointing to this 1 position over here. Next, we are going to compare between 2 and 3 again. Is 3 less than 2? Well, it's not. So this 2 gets stored over here. Our P2 now points over here because P2 is incremented from 1 to 2. And our P1 is still at 0. Also, I gets incremented from 0 to 2. So our next comparison is going to be between 3 and 3 again. So since 3 is not less than 3, this 3 goes over here and really doesn't matter which 3 gets stored first because both are essentially the same values. Okay, so our P2 now points over here and our P1 still points at 0. I gets incremented again. Now we compare between 4 and 3. Now this 3 is, since it's less than 4, gets stored over here. And our P1 finally changes from 0 to 1. P2, there's no change in P2 in this iteration. I gets changed from 3 to 4. Now next we are going to compare between 5 and 4. Now since 4 is less than 5, we are going to store 4 over here. Our P2 changes from 3 to 4. But you see, there's no value at 4. P2 has reached the end and P1 is still at 1. So what are we going to do about the rest of these spaces? Well, since this array is already in a sorted order, we know that all of these values are going to be less than these values. So all we have to do is copy these values over here and our final array is going to be in a sorted order, right? So this is all we have to do. So let's look at the code for this. Again, we are accepting the length of both the arrays. But since our arrays has to be in a sorted order, we are not generating random values. Rather, we are accepting the input from the user. And this is the main logic for our program. Our third array is the length of our third array is going to be a summation of the length of array 1 and array 2. And look closely at this while condition over here. So before that, all of our P1, P2 and the I index of the third array is initialized as 0. And this condition over here basically ensures that this loop is terminated as soon as either of the array is fully traversed. For example, in this case, the example that we took, P2 was traversed, the array 2 was traversed first and this condition became false. So till then, what we have to do is we have to compare the values at position 1 of array 1 and the value at position 2 of array 2. If it's smaller, then we simply assign that value to array 3 and we increment our P1 or position 1. Then if that is not the case, then we do the exact opposite. We store the value at position 2 of array 2 and we simply increment the value
of position 2. And at the end of these comparisons, well, our I value or the index value is always incrementing after each iteration, right? So once this condition is satisfied, evaluated to false, all we have to do is copy the rest of the elements from the first array to our third array. And how do we do that? Is that we run this loop until this condition is evaluated to false, and we simply copy the elements. Okay, so instead of writing these two lines, incrementing the p1 and the I value, we can simply do post increment operation over here, and this can be done in one line, but according to me this is not as much readable as just including these two lines over here. So the question arises, how did we know that the first array is always going to be uh, the second array is always going to be traversed first? Well, we don't know that. So we are going to write the code to copy the rest of the elements from both the arrays. As you can see, both of these code is identical, and it's simply copying the rest of the elements from array 2 to array 3. But since this value, this condition was evaluated to false, and at position 2 reached the value 4, so we will not, the example that we took, we will not be entering this loop over here. So the code is there, but we are not going to be entering this loop, and this code is not going to be executed. So if we quickly look at our demo over here, and after that we are going to simply print out the values. Okay, so that's all we have to do, and let's just quickly take a look at the demo. So the length of our arrays are 3 and 4, and the values were 3, 5, 6, and 1, 2, 3, 4, and this is our finally sorted arrays. So just to recap, run this loop till either of the arrays are traversed, and then simply copy the rest of the elements to our third array. And how do we know which array is going to be traversed first? Well, we don't know that, but these position 1 and position 2 counters and these two conditions are going to take care of that for us. So hope you enjoyed today's video, and thank you.